in that the net rate of disappearance of A minus DCR is in DCR by dt, sir. That DCR by dt, why we are putting
DCR by dt. Here.
Yes, sir.
Here.
Yes, sir.
Either you can write for the net rate of disappearance of A or net rate of appearance of R. That is why minus DCA by dt is nothing but DCR by dt. How much it is disappearing, that much of R is being formed, right?
Yes, sir.
So either you can write for the disappearance or appearance of R. Both will be same. But we are taking only disappearance of A. Only raw materials will generally use, not as a appearance for the R. So either of it, the equation is same. That's what in the previous thing itself I told. But if you want the relationship between both, then that's what. If there is any coefficients, this disappearance divided by that coefficient, and this appearance divided by that coefficient you put. That is what we did in the first class itself. If you want the relationships between both, if there is any stoichiometric, then it will be different. If the stoichiometric is only 1, then both are same.
Okay, sir.
If there is a 2A gives R, now I'll just put here. If there is a 2A gives R, like once, let me, because I have to blow it up, then only it comes. Now, if there is 2A gives R, where is it? When 2A is giving you R, then here what you get minus dou CA by dou T divided by 2 is equal to dou CR by dou T divided by 1. Here it will be different because you are getting different stoichiometrics. If the stoichiometry is same, then both will be same. That is equal to, again here, what is that? Minus K1 CA square, if there is a second order, by 2 also will come, minus K2 CR. This is K1 and K2. Since it is same, you are not putting like K1 CA minus K2 CR. That is for the rate of disappearance of A minus. Okay.
Yes, sir.
Any other doubt?
Yes, sir. Concentration of R at time t, Cr is equal to Cr naught plus Ca into Xa, sir. So Cr naught will be the
Here.
in the yes, sir.
Cr naught is?
Cr naught is initial concentration of R will be
R.
0, sir.
Yes, it will be 0. But
So
still, to write in the same form, I am just writing here. But actually, it will be 0.
Okay, sir. And
initially, R is not there. But for a what do you call this type of reaction, autocatalyzed reaction, some of the R is present. That is why I am putting this as constant. Here, Cr naught will not be 0 because some R should be present.
Okay.
That is why you get this curve, that inversion. That is why it is starting with this and then goes down.
Okay, sir.
Yeah. Yeah, you are asking something. Is it clarified or still you want?
Yeah, plus Ca naught into Xa, sir. Why we are putting like
because Ca naught Xa is nothing but Cr naught X naught. Because that is what we did earlier. If the number of moles are same, how much of A is formed, that much of R is how much of A is disappeared, that much of R is formed.
Okay. Okay, sir.
That is what earlier we got it, right? The first A plus B gives product. We substitute B. I'll just show you that. Some of you who is joined now, please bear with me because I think Niveda is asking some doubts, so you can also clarify yourself if you are having doubt. I'll just show, I'm just going back to the previous slides. Yeah, now A plus B gives product. So I didn't put that A plus B is product here. I'll just show you in. I'll just show you here because in that I didn't put it. Yeah, A plus B gives product. I think now you see you are writing KCACB. So
Yes, sir.
CB is CB naught into 1 minus XB. But here you are noting that the amounts of A and B have at that time, anytime react at any time are equal. So CA naught XA will be equal to CB naught XB. That is why CB naught XB you are writing as CA naught XA. And this CB naught you will just do like MCA naught.
Yes.
Correct.
CB not the CM.
MCA naught, right? That is what,
Yes.
yeah, since M is CB naught by CA naught. So you are trying to eliminate B. You are writing the B, all B in terms of A. Now, if
Okay.
there is a stoichiometric coefficient here, 2A plus B gives some product, then how much of A is disappeared will not be equal to how much of B is disappeared because there is a stoichiometric coefficient.
Okay, sir.
So that time you have to put that stoichiometric down and then equate it. How much of A is reacted and how much of B is reacted. That is what earlier in my
Minus
first
uh,
in my
the
first
supplement
slides I showed you, this.
minus RA by the
Yeah, here,
supplementary
see. Minus RA by 2.
to
This is the coefficient. Minus RB by 1 is RR by 3. That is why this equation plays a very important role. This gives how much of A is reacted and how much of B is reacted and how much of R is formed and the relationship between how much A is reacted to the how much B is formed. Now, if you are comparing here A to R, then if you compare these two, then the rate of disappearance of A is 2/3 the rate of appearance of R.
um,
That's understand.
yes.
So
Yes.
accordingly, your CA naught XA will not be equal to CB naught CR naught XR because it will
Okay.
be to the fraction of to this particular thing.
Yes. Okay, sir.
Okay. Yeah.
Yes.
Any other
Thank
doubt, ma'am?
you, sir. No, sir.
Okay, good. So
Thank
welcome to the class, all of you. I think so a lot of people are waiting for 10 minutes. Niveda is asking some doubts regarding the derivations. I think she might have done some derivation. That's why she is getting doubt. Again, I repeat to you, if you do derivation on a paper, take a pen paper, you get n number of doubts. I again bet if you are not getting any doubt, that means that you didn't do anything. Okay, so try to do, then you get n number of doubts. It's not again that easy to do a partial fraction. Understand? The mathematics part is very tricky there. What Niveda asked is just a mathematical part, how it is being done. Especially if you see in the Levenspiel book, they won't give you any derivation. They won't give you any derivation. Just straight away they will give you. You see, if you if this is the A plus B gives a product. So from this step, you do a partial fraction and then do the integrals. You get this. That's how they will give. From here to here, if you do in a book, it takes more than 1.5 page. Understand? So any book, he won't give you entire full derivation. He will skip a lot of steps. So if you do only, you will understand each one. Here it is having 1, 2, 3, 4. 4 expressions are there. And here in the right hand side, there are 2 expressions. If you want to do all the expressions, it takes more than some 2 pages in your notes to get from this form to this form. Some of the things I did it, but again, I request you to do so that you get a number of doubts. And I'm happy to clear all your doubts. I know what doubts you will get. If I tell now, you won't appreciate it. I think now Niveda might be knowing what she asked, and she might be very satisfied with the answers what I gave. Other people, it may be just like a Greek and Latin because you don't know what I'm talking, right? So please start doing the derivation, then you get a number of doubts. Then only you will get the flavor of that CRE. Otherwise, it will be just like if I show you cat, if I tell it is cat, it is cat. If I show you dog and if I tell it is cat, you have to agree it is cat because you don't know, right? If you do only, you can tell that, no, sir, you showed dog, it is not cat, right? So please try to do it. Then you get a nice fun in the especially CRE. CRE is a very funny subject, really. Again, I repeat to you, CRE is a very funny subject. At the same time, it is one of the difficult subject. If you can understand and if you can get mathematics correctly, it will be the funniest subject. Even CRE2, it becomes much difficult because mass transfer will come into picture, right? So let us do some problems. Today we'll wind up the first unit. Before that, there is next week you are having the exam. So the exam pattern is 12 multiple choice questions, which I'll put in a assignment. The assignment, like a question paper, I'll put. So 12 multiple choice question, each of 1 mark. You can write only answer on a paper, right? Just like a normal paper, you start writing part A, and part B contains 3 questions of 6 marks each. Part C contains 2 questions of 10 marks each. So total 50 marks. Part A is 12, part B is 18, part C is 20. So 20, 18, 12. Therefore, it is 50. So all the 3 parts you can write on a paper, A4 paper, and then try to upload just like I upload like a assignment what I put it, right? Any doubt in that pattern? So this is the pattern I think all the people will follow. And the other thing what I like to show, I'll just show you because I don't want to. I think you are seeing my screen, right? You are seeing my screen, right? So let me
Yes, sir.
show you something. This is the LMS page. I think you might be noticing all that. So attendance you can see, and I put the 11 spell books and university question papers also I put. I put my class notes also. What I showed in the previous class, that is your seniors notes, my own class notes. So those people who want to do problems, what I did, you can see in this thing. The other one, lecture, whatever I showed you. And here I put all the videos till now. Some last 2 classes I didn't put. I'll put because I have to download and then upload here. And this is the tutorial which I put. For this tutorial, what I put, you can see 65 people are there, only 55 submitted. I think I graded 10 people initially. Afterwards, I didn't have time to see what you put it. So what happened to the rest of the 10 people? You want, shall we, you want me to show who didn't do it? Huh? I don't want to do because people know who didn't do. I don't want to tell in front of all the class. Again, I tell to you, for you, there is 40 marks internals, which comes, 30 marks comes from your 2 cycle tests. 10 marks I have to give for the assignment. If I conduct only one assignment, so only 55 people will get 10 marks. Rest of the 10 people will get only 0 mark. Is it okay for you? Later, don't ask me that I get internals less marks. I gave enough time, at least if you, some people they send to my mail, that I consider. I'll give that particular people some time so that they will upload in this, so that there won't be any confusion. Maybe some 2 people they sent to my mail, out of which one girl she told that already she uploaded in the LMS. So one boy extra, one boy it came. So 56 came. So 9 people. So it's up to you. It's you want mark, you submit. If you don't want mark, then later don't ask me that I'm getting less marks. Because everything is open here. You submit, you get marks. Forget about what you did inside. Right? So whether I'll just see what is your attempt. Whether it is correct or wrong, that I'll see later. But your effort should be there, right? So That's up to you. 9 people. So those people who 9 people who didn't do it, they can personally call me or even send a mail to me so that we'll see what to be done, right? So I don't want to name them now here. Okay, that is what I just want to show you. Now let us go to the next question, which is very important, especially when you are doing a variable volume batch reactor, right? Yeah, please take this problem. Determine the value of first order rate constant. Yeah, please write this question and then we'll do the answer there. Determine the value of first order rate constant K for the disappearance of A in a gas phase reaction. I think, shall I increase a bit size? Is it okay? Shall I increase the size or is it okay, ma? Shall I increase?
It is
Increase.
Shall I increase the zoom it? No? It is sufficient? Okay, fine. Determine the value of the first order rate constant for the disappearance of A in a gaseous reactant. 2A gives P. Since he gave gaseous, that means that it is a variable volume, right? So 2A gives P. Here itself, you know, the number of moles is decreasing. So you have to get the expansion factor into picture. If on holding the pressure constant, he himself is giving pressure constant in the sense variable volume. The volume of the reaction mixture starting with 80% of A. So 80% of A. Then the rest of the thing, 20% will be the inert. Decreases by 20% in 3 minutes. Decreases by 20% in 3 minutes. The volume of the reaction mixture, the volume is decreased by 20% in 3 minutes for this particular reaction, which is having A as 80%. Rest of the 20% is inerts. Yeah, can you find out how much is the expansion factor for this 80% mole fraction? Yeah, please tell me what is the, all of you wrote the problem. Yeah, again, I'm telling you, CRE, please try to keep a separate notes because it will be useful for your higher education, especially if you are trying to write a CAT or sorry, not CAT, GATE, right? So your own notes, it will be much helpful. Yeah. So reaction is given. Since it is a constant pressure process, the way volume is changing and he is giving you gaseous phase reaction. So definitely the volume is changing. 80% A and is giving you that the volume is decreased by 20% in 3 minutes. So when it is happening, he is asking you to calculate the first order reaction rate K. How to find out the K, right? Yeah. Yeah, this is the problem I think which I gave. This how last time we did it, right? Last time to your seniors, they did like this, the same problem, right? 2A gives R, the pressure is constant, 20% of A is there, therefore 20% is in it. In 3 minutes, it is decreased. That's what he gave. Decreased by 20%. How much time he gave? The same problem or different? 20%. So 20% in 3 minutes. That we'll see how we do. So K is asking you to find out. K is asking you to find out. You know it is first order reaction. Therefore, minus ln 1 minus XA is KT. I'll just blow it up so that you can see properly. Is it fine? Yeah. Now you see. Minus ln 1 minus XA is KT. So we need to find out this K. We need to find out this K. But this is constant volume batch reactor. But we know it is variable volume. For a variable volume, we know that V is V naught into 1 plus sigma A XA. We need to find out this sigma A. How to calculate this sigma A, right? So what we do here is, we'll first calculate epsilon A. epsilon A is V of XA is 1 minus V of XA is 0 divided by V of XA is 0, right? So let us put in a tabular column, VXA is 0, VXA is 1, A inerts, R is the product and total. I think the reaction is different. I think P is giving you a P. You put R, huh? You put R so that the solution will be equal. Huh? I'll just blow it up. Yeah. So 0.8 A at initially, 0.2 inerts, R is 0. The total is 0.8 plus 0.1 is 1. A V of XA is 1, that is volume at final conversion. There won't be any A because XA is 1. The total conversion, A won't be there. Inerts it will be present. R, how much it will be? This is 2A gives R. So A is giving you half R. So you can write there that A, whatever. So I think I cannot write here. I don't know what happened. So A is giving you R. So A is giving you half R. So half times A is nothing but 0.8. So it is R is 0.6, 0.4. So total will be 0.2 plus 0.4 is 0.6. So how much is epsilon A? 0.6 minus 1 divided by 1 is minus 0.4. Correct. Now what we have to do? He is giving you one more thing. In 3 minutes, the volume is decreased by 20%. That is what he give. So let us assume V is V naught is 1 plus sigma A XA. So from this, can we calculate XA? Because XA is 1 by epsilon A, V minus V naught by V naught. I just take V naught divide, and then 1 you take this side and take LCM. What do you mean by this? V minus V naught by V. V is nothing but the final volume. V naught is nothing but the initial volume by initial volume, right? So this is what is giving you 20%, decrease of 20%. So V minus V naught by V naught is nothing but the percentage of volume reduction. Since it is decreased, I am putting minus. So this value is what he gave you here. So minus why we are getting, because the volume is decreased. If the volume is increased, you put positive. If the volume is increased, you put positive. That will happen when you are getting A is 4R. The volumes are increased. Therefore, you get here positive and here also positive. So here, this particular quantity is 0.2 and this is minus 0.4 because this. So minus minus get cancels. XA you are getting as 0.5. Once you get XA, then substitute here. Substitute here minus ln 1 minus XA is KT. Time is t minutes, 3 minutes. XA you calculated. K you can find out. 0.231 minute inverse. So here one important catch is this. What is this volume reduction? Volume reduction is nothing but V minus V naught by V naught. Final volume minus initial volume by initial volume. That is the percentage. If you want to write you put into 100, then you get into percentage. Otherwise, if you want to put in terms of less than 1, this is for 20%, therefore 0.2. Okay. Any doubt, my here?
No, sir.
Now, can we do one more problem like this? One more
Yes, sir.
problem like this will do,
Yes,
which
sir.
is much difficult. 1 second. Let me do A is 2.5 R, right? This problem, lot of times they asked in the exams. That is why you put a star. Huh? That problem I'll show you. You can write that problem. A is 2.5 times R, right? Yeah, this problem. Yeah, this a lot of times they ask this problem if you see any question papers, this is the general problem which they'll give. So the first order homogeneous gas phase reactions. Yeah, please write down. First order homogeneous gas phase reactions. Gas phase. So gaseous phase is giving you, that means you have to calculate the expansion factor, right? As long as he's giving you liquid phase, so no need for you to do, right? Only for a gas phase, the volume will be changing because you are trying to keep the pressure constant. Yeah, A gives 2.5 R. Is carried out in an isothermal batch reactor. Is carried out at isothermal batch reactor. At isothermal batch reactor. At 2 atmospheres. At 2 atmospheric pressure. With a 20 mole% inerts present. So A is only 80%, right? Inerts is 20% inerts present. And the volume increases by 60% in 20 minutes. And the volume increases by, so since he is giving you increase, that means V minus V naught divided by V naught will be positive quantity. That is what you can see here. This is 2.5 minus 1 is almost 1.5 plus, right? So from the here reaction itself, we know whether the volume is increasing by some percent or decreasing by some percent. 60% in 20 minutes. Right. So in case of a constant volume reactor, is just comparing constant pressure and constant volume. So with this data, if this reaction is happening in a constant volume reactor, determine the time required for the pressure. Determine the time required for the pressure to reach 8 atmospheres. To reach 8 atmospheres. If the initial partial pressure or initial pressure is 5 atmospheres. 5 atmospheres, 2 atmospheres of which consists of inerts. 2 atmospheres consists of inerts. So a lot of pressure data is giving you, right? I'll just repeat the problem, just see what you are writing. The first order homogeneous gaseous reaction A is giving you 2.5 R is carried out in an isothermal batch reactor at 2 atmospheric pressure with 20 mole% inerts present, and the volume increases by 20% in 20 minutes. In case of a constant volume reactor, determine the time required for the pressure to reach 8 atmospheres if the initial partial pressure is 5 atmospheres, 2 atmospheres of which consists of inerts. Did you understand the problem first? Forget about the solution. Did you understand the problem? Yeah. Okay. Can someone explain what is the problem? Yeah. Some of you. Yeah. Make a try. No problem. You go wrong, I know, but still, at least the effort is good. Yeah. Someone want to talk, or shall I explain to you what is given in the problem? What you have to calculate? You want me to explain, or some of you will try? Okay. I think no one is going to I'll explain the problem. First, you need to understand the problem. Then only you can do the problem, right? So the problem what is giving you is there is a reaction happening. A is 2.5 R is a gaseous phase reaction. So the number of moles are increasing. That is what you can see from that, right? So this reaction is a gaseous phase reaction and is giving that it is happening at 2 atmospheric pressure. And the reaction in the reaction, there is only 80% of A present. This reaction is happening for 20 minutes. When the reaction is happening for 20 minutes, in this variable volume batch reactor, the volume increases by 60%. That is what he gave. Now, using that from that particular data, you need to get the K because that is what you need to get. That is the rate constant. Rate constant is constant at a particular temperature. So you need to get the K data from that. The second bit, what is asking you, if this reaction is going to be used in a constant volume batch reactor, that means pressure will change. Am I right? In the earlier case, it is keeping at a constant pressure, that is 2 atmospheres. Now, if the same reaction is happening in a constant volume reactor, determine the time, how much time is, because you know that constant volume batch reactor, the pressure will change. How much time will be required for the same reaction for the pressure to reach 8 atmospheres, because initially it is 2 atmospheres. So to go from 2 atmospheres to 8 atmospheres, how much time is required? Out of this particular thing, if the initial pressure is 5 atmospheres, so it is starting at the initial pressure of 5 atmospheres. Out of this 5 atmospheres, 2 atmospheres is inerts, because you know that entire A is not present. Inerts are present, so inerts also will exert some pressure. So the total pressure is 5 atmospheres, out of which only 2 atmospheric pressure is exerted by the inerts. Rest of the thing, that is 3 atmospheres only, is exerted by the PA. Now you understood the problem, what, or you want me to repeat again the understanding of the problem? So if this reaction is going to be a constant volume reactor, he is asking you how much time is required, right? Yeah, can you do this first? What is the expansion coefficient with this particular data? 60% is the, sorry, 80% is A is present. Yeah, please do expansion factor. How much you are getting? Let me know who is doing. Yeah, someone of you do. How much is the expansion coefficient? Emma? Yeah, this is the problem. Gave a lot of times. I'll just try to put over it. So A is 2.5 times R. So once you know the problem, you have to write the given data. Given data is A is 2.5 times R. So it is happening at 2 atmospheres. 20% is inerts. Volume increased by 60%. That is what he gave, or other thing. Sorry. Yeah, 60% volume is increased. So volume is increased by 60% in 20 minutes. So that is the case number 1. He's asking you for a constant volume, what is the time required to go the pressure to 8 atmospheres, initially starting at 5 atmospheres. Out of the 5 atmospheres, 2 atmospheres is inerts. Right? Now what to do? This is a first order reaction. Did he give? It's a first order homogeneous, right? So since it is a first order reaction, we know that minus ln 1 minus xa is kT. So he's asking you what is this T. So he gave 60% volume increase. So V by V minus V naught by V naught is plus 0.6. Whereas in the previous problem, we put as V minus V naught by V naught is minus because the volume is decreased. This is the given data. Okay. So always when you are doing a problem, write a given data and then write like this. Then write the equation to be used. put a question mark to whatever you want to calculate. Then start doing it. Then it will be easy, right? So again, I repeat to you, if you want to go with this solution, you go. But I am having my own way of doing because this it takes to a lengthy process. So it's up to you. If you want to follow this, you follow, right? So generally the solutions I won't follow from the book. I have my own solution, but the meaning will be same. Don't think that this is having some solution and I am having some other solution, but the answer will come same. So different way of doing it, right? So that's up to you. How you want to do it. What I am doing is just a Levenspiel way of doing. If you see a Levenspiel book, you get this type of solutions, right? So V minus V naught by V naught is 0.6. We know that V is V naught into 1 plus epsilon A XA. So we can write V minus V naught is epsilon A XA. From that XA, we can calculate 1 by epsilon A, V minus V naught by V naught. Let us do what is this epsilon A. How much is the epsilon A? We know that Vxa is 0, Vxa is 1, A, inerts, R and total. So A is 0.8, inert is 0.2, R is nil, total is 1. So V at Xa is 1, A is 0 because at a final conversion, entire A will react. Inert is same, it won't take part in the reaction. R, how much is R? 2.5 is there. So 2.5 times how much of A is being there. Therefore 0.8 into 2.5 will give you 2. The total will be 2 plus 0.2 plus 0 is 2.2. Epsilon A is 2.2 minus 1 divided by 1 is 1.2. The same thing you get here, 1.2, right? So forget about what expressions he is using, all that, because he is trying to use the same expressions what he derived. Since we didn't do derivations, we had only one equation in picture, minus ln 1 minus xa is kt. We'll keep the same thing. Let us not trouble with the different formulas. If you can remember, you remember, then straight away you put it. So what I am trying to do is, I am remembering for a first order reaction only this. And from this only I will derive. I'll just try to include for the variable volume. Whereas this particular formula is for the variable volume. I don't want to remember this. Understand? So instead of remembering, I'm just trying to do this. I'm trying to calculate and then substitute. Okay. Now what to do this? So epsilon A is 1.2. Now calculate XA. You are getting V minus V naught by V naught is 0.6 plus 0.6. Epsilon A is 1.2. So you get XA as 0.5. The same thing you get here. XA, where he is doing. XA is 0.5. So whatever way he is doing, you will get the same thing. So conversion is 50%. Right. So next we'll do. Now you substitute in this particular formula, you calculate how much is K, because we need to have K. So how much time is required for this? It is requiring 20 minutes. So substitute T as 20 in this and then calculate the K. So the first case, always anytime he gives you two cases. For the first case, you need to calculate the K because K remains same. As long as the temperature is same, your K remains same. What problems I'm doing is only for a constant temperature. Okay. So K is this particular thing, minute inverse. This is the unit for the first order. Now the second case we will get. What is the second case? Is asking you for this kind of reaction. If you are going for a constant volume reactor, I take a same constant volume instead of variable volume. So how much time is required for this reaction to go from 5 atmospheres to 8 atmospheres? Because one constant volume means temperature, pressure will change. So how much time is required for the pressure to change from 5 atmosphere to 8 atmospheres? Out of the 5 atmospheres, 2 atmospheres is given by inerts. So let us use the pressure equation now. Now what is PA naught? PA naught initially is 5, but out of which 2 atmospheres is inerts. Therefore PA naught becomes 3 atmospheres. Correct? Any doubt here? Because 2 atmospheres is by inerts, because A plus some inerts are present to give you 2.5 R plus inerts. So PA naught is 3 atmospheres. XA is nothing but 1 minus PA by PA naught. But we don't know what is PA. This PA is 8 atmospheres. This PA is the total PA. The total PA of what do you call pressure, which is given by A and then inerts. So we need to calculate only PA. How much is PA? So PA, we know that PA naught minus A divided by delta N, P minus P naught. This is the expression which we got from this particular equation. I think you might be forgetting that we did some derivation initially to get pressure data. I'll just put that. Where is that? You're not getting that. I think it is not there in the slide. I will show you here. Yeah, going back and front. So this is the expression, right? PA is PA naught minus A by delta N pi minus pi naught, right? So what is pi naught and PA naught? That is what I'm just showing you here. So PA is PA naught minus A by delta N, P minus P naught. Now what is PA? PA is the pressure, final pressure. PA naught is the initial pressure. Initial pressure. A is nothing but what is the coefficient of A. Delta N is nothing but the coefficients of product minus the coefficient of reactants. P minus P naught is nothing but P is the total pressure. P naught is nothing but the initial partial pressure of the reactant. Now what is PA? PA naught is nothing but 3. A is 1 divided by 2.5 minus 1 is 1.5 into P. What pressure is that? Total pressure. That is what I showed you here. Yeah. Pi minus pi naught. Pi is the total pressure. Pi naught is nothing but the total pressure initially, right? So P minus P naught, that is what I'm using. P is nothing but total pressure, that is 5. P naught is nothing but 5. That is the initial total pressure is 5, out of which PA naught is 3. So try to remember P naught, PA naught on PA. PA is the final pressure of A. PA naught is initially what is the partial pressure of A. P is the final total pressure. P naught is nothing but initially how much is the pressure. This initial pressure includes the inerts. If sometimes there are no inerts, then this P naught is equal to PA naught because there is only one. Only P is there. Therefore, P naught and PA naught become same. Since there are inerts present, this pressure is different than this pressure. So 3 minus 1.5, 8 minus 5. If you do that, PA is 1. PA is 1. That is final pressure, which is exerted by A is 1. So now you substitute in this, XA is 1 minus PA by PA naught, 1 by 3. Therefore 0.66. This is 67% conversion. Whereas previously it is only 50% conversion. Because of this variable volume, the conversion is 0.67. So when you are having 67% conversion, again you substitute in this because K, you know, conversion is 0.67. Then time you can get it is 32.31 minutes. Yeah, any doubt, ma? This is how you have to do. Yeah, I know you will get a lot of doubts here. Yeah, if you follow, you could have got a lot of doubts here. Again, I tell you, you do some problems in which is given in the Levenspiel. This is the Levenspiel book. Already I put it. He gave some problems at the end of this. You try to do that problem, then you will get this P is different, this PA naught is different, this pi is different, and this pi naught is different. So you have to get what is that. That is what he is giving you. Conversion or a partial pressure. PA is the partial pressure. Total pressure is pi at time t. Initial partial pressure of A is PA naught. and initial total pressure of the system is pi naught. Pi naught is always initially. Pi and PA is at the final. P gives you partial, pi gives you total, right? So that is why he gave in terms of pi minus pi naught. But somehow I am comfortable using like a P naught like that. P is the total pressure, P naught is nothing but initial total pressure. So if you are comfortable with this kind of notations, you use the same notation. That's up to you. Okay. Yeah, any doubt here?
Sir, that X is equal to 1 minus PA by
1 by
PA
3.
naught.
Yeah.
How are
You
we
know that
getting
XA
it?
is 1 minus CA by CA naught, right? CA is CA naught into 1 minus XA.
Yes, sir.
Yeah, from that XA is 1 minus CA by CA naught.
Yes, sir.
What is CA? You can write CA in terms of PA. PA by RT is CA.
Yes, sir.
So
Okay.
PA by RT and PA naught by RT. RT gets cancelled out.
Okay.
Same, right?
Okay.
So you get XA is 1 minus CA by CA naught or PA by PA naught. Anything you can write.
Okay.
Okay.
Yes, sir. Okay.
Yeah. Any other doubt? This is a very important problem. Lot of times they asked. So let us do one more problem. It's a zero order reaction. Zero order reaction. Where is this zero order reaction? Yeah, you have to search for the problem. I think it is at the back itself. What is A gives RR, right? A gives RR, right? Yeah, I think it is there at the back itself. For this, I'm just want to show you the problem. That is why I'm just rolling here back and front, because I can dictate the problem I'm having in my own notes, but I don't. Yeah, this is RR. Yeah, this. I think. Yeah. Please write this. Yeah, what problems I'm doing in the class? These are all lot of times it came in the exam, right? So I'm giving preference to only the problems which came in exam. So that does not mean that rest of the problems you should not do. You can do, but the time, right? Huh? Now a zero order homogeneous gaseous reactant A is giving you RR, takes place in a constant volume bomb or reactor, whatever you call it, right? So this is a constant volume. P is 1 atmospheres when T is 0, and P is 1.5 atmospheres when T is 1 minute. So as the reaction proceeds, the pressure is increasing 1.5 because it is taking part in a constant pressure volume. Therefore, pressure will change. If the same reaction, same feed composition and initial pressure proceeds in a constant pressure apparatus, right? So earlier problem is gave you first constant pressure, then is asking you to go for a constant volume, but here is giving you constant volume first, and then if it is going in a constant pressure, find the volume at T is 1 minute, if V is 1 liter, at T is 0. The order is 0. The rest of the thing is same. Order is 0, right? Order is 0. Yeah, please write down the problem. A zero order homogeneous reaction takes place. A zero order homogeneous reactions. No. I think this problem is different than what I am having. I think. Yeah. 1 second. 1 second. Don't do that. I think that this is not the problem what I am having. Yeah. I think this. Sorry. This problem is what I'm having in my own notes. This problem is the notes. So a zero order homogeneous gas phase reaction with a stoichiometry A gives RR. Proceed in the previous problem. You can just keep some gap so that you can do later, right? Don't strike out. you write this problem. A zero order homogeneous gaseous phase reaction with a stoichiometric A gives RR proceeds in a constant volume bomb with a 20 mole percent inerts. So he is giving you inerts. The pressure rises from 1 to 1.3 atmospheres in 2 minutes. Just a volta, right? Earlier case is giving you constant volume pressure. The volume is changing, but here is giving you, since you are putting at a constant pressure, constant volume, pressure is changing. If the same reaction is carried out in a constant pressure batch reactor, what is the fractional volume change in 4 minutes? So he's asking you V minus V naught by V naught. In the earlier case, he gave you what is V minus V naught by V naught and is asking you what is the time required. But here he's giving you, he's asking you to calculate this in 4 minutes. If the feed is 3 atmospheres and contains 40% inerts, 40% inerts. Please write it fast. Yeah, Guru, you can take the attendance now. Yeah, please take
Yes,
the
sir.
attendance. Exam, I already gave the syllabus. First unit is the syllabus. Next week, you are having classes or not? After the exam, you will have classes, right? What did they tell to you? No class?
They didn't inform us about that.
You didn't inform, then I'll take class if you are free, because I need to have some periods. Already HOD, on the day I informed HOD that I got only 3 periods, where it is a 4 credit course. I require 60 periods. So I need to, you need to give me some free time for me to take the class. Or if you want to can read, it's up to you. But if you want me to complete as per your satisfaction, I require some extra free period. Whenever you are free, just send a message, then I'll join you. Okay. So you discuss with your friend and then come to me. Guru, you can discuss with your friends. Give me some free time, free periods, or even Saturdays. I'm open to Saturdays also. So, but you need to tell me before whether you are coming or not. Okay. Yeah, talk with your friend and then come. Okay. This is the problem.
Yes,
Then I'll give you the solution. Now you see a zero order. A is giving you RR, constant volume batch reactor, 20% inerts. The pressure is changing from 1 to 1.3 atmospheres in 2 minutes. So in a constant volume batch reactor, if the same thing is happening in a constant pressure batch reactor, what is the fractional change in volume? That is what I asked. So 4 minutes is giving you. In 4 minutes, the reaction is happening. What is this? The feed is 3 atmospheres, out of which 40 atmospheres is inerts. This is what he gave. So you know at a zero order reaction, Ca0 minus Ca is Kt. This is the expression which you will get when you do derivation. So since it is a constant, what do you call, volume reactor, we can write Ca0 is Pa0 by RT. So Pa0 by RT, Ca is nothing but Pa by RT is Kt. So if you do this expression, the name derivation for a variable volume, this is what you get. Ca0 by epsilon A is ln V by V0 is Kt. So Pa0 is 3 atmospheres. That is he gave you. Pa0 is 3 atmospheres. So this is the expression which you get in terms of variable volume. Ca0 is nothing but Pa0, Pa0 by RT into Ca is ln V by V0 is Kt. So here pressure is changing from 1.3 to 1 to 1.3. So P is 1.3 and P0 is 1. So if P0 is 1, Pa0 will becomes, because 40% is inerts, 40% is the inerts which is being present. Therefore, P 40% less or 0.6% will be giving equal to 0.8%, right? So since this particular percent. So you put in terms of this expression P minus Pa0 A by delta P. P is 1 delta n is nothing but r minus 1. R is not giving any coefficient. So PA becomes 0.8 r minus 1.1 by r minus 1. This is what you get, because since he is giving you in terms of some coefficient r, right? Any doubt here? This expression, what I put in this, you have to derive it. This is the derivation for a zero order variable volume batch reactor, right? So still if I just substitute whatever is given here, then you can get, you need to get this particular thing, what is epsilon. So for epsilon, you are calculating this. V of XA is 0, V of XA is 1. So A is 0.6, inert is 0.4, R is 0, total is 1. So PA is 0.6, inert is 0.4. R will be 0.6 times, because 0.6 times R. So total is 0.6 R plus 1 what do you call 0.4. So epsilon A is nothing but 0.6 R minus 0.4 minus 1 divided by 1. Am I right? So that is what you get. And if you substitute entire thing in this particular formula, you are land with V minus V naught is 22.14%. Please try to do this problem. This problem is a very famous problem. A lot of times they asked. So try to do, and if any difficulty is there, you can approach me. Okay. So with this, I complete the first unit. Still lot of problems, different kinds of problems are there, but still we need to go on for the next topic, that is the reactors. Now in the first unit, you saw different kinds of reactions. The second unit will see different types of reactors, right? So with this, I stop, and then I know you'll have a lot of difficult, what do you call, doubts. You can pose whatever doubts you want, right? Okay, then thank you.